Hi viewers, welcome to LMS Solution. Today we are going to see about step-by-step implementation of 3 megawatt grid connected solar PV system. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. So first we have to take the PV array. So here I'm going to use the same PV model that means 213.15, and then here I'm going to consider 11 panel in series and then 1300 panel in string. Okay, that means for example you can say 11, right? 11 into this 29, that means voltage at maximum power point is 29, right? So that means it's around 11 cross 29. Okay, that means here you can see here that voltage. So we have that voltage is around 319 volt, right? And maximum power is 3.04 megawatt, and also you can see the current at is around 9 triple five. It's okay. So this kind of panel we are going to use, that mean 11 panel series and then 1300 panel are parallels. Okay, that means the panel is connected, that series string is connected 1300 times. Okay, so next I'm going to use constant. So the constant is used for providing input for the irradiation and temperature. So this is 1000. So this is 25. So next we need to use boost converter. So I'm going to use double stage conversion. Okay, so we need to use boost converter. So for that I'm going to use RLC series branch, and then I'm going to connect this one here and this one here, and this need to be changed to C, and then we need inductor. So here we have inductor, and then we need IGBT switch. So I'm going to use IGBT switch here, and then we need diode. So I'm going to use diode, and then we need output capacitor. So I'm going to connect this one. So we need to measure output voltage. So I'm going to use voltage measurement, and then I'm going to name it as, I'm going to use go to block to navigate the signal to some other place. So I'm going to use this one as PDC. So next I'm going to measure PV measurements. So I'm going to connect go to block here, and then I'm going to change to PV measurement PVM. So I'm going to take this one. So here I'm going to use P, that mean MPPT algorithm, to control that boost converter to extract the maximum power. So here I'm going to use bus selected, just go to connect bus selected here, and then select VPV IPV, and then we need to use FCN, not FCN, MATLAB function. We need MATLAB function to implement that MPPT. So I'm going to use this MATLAB function. So I'm going to click this one. So already we have that PO method MPPT code, right? So once again I will open that one. So this is a code code for that PO MPPT. Just I'm going to copy this one, paste it here, and this is going to be considered as T reference. So this is, I'm going to change to MPPT. The input will be the voltage and current of PV, and then initial, this is initial duty cycle. So this is maximum duty cycle, this is minimum duty cycle. So this is change in duty cycle. So this is previous duty cycle. and then just you go to change that V to D, right? So next you go to change here, just you go to change this one. So about this MPPT, so already I have explained in my YouTube channel, so you can refer that video also now to get that clear idea about this into MPPT. Now you can change this previous instant duty cycle power and voltage with the current instant duty cycle power and voltage. So this is a code for that P and MPPT. So I'm going to use directly. So here you can see that you have that MPPT detail, right? So I'm going to connect this VPV and IPV, and then this should be processed via PWM generator. So I'm going to use the PWM generator, and then output will be given here. So here I'm going to use switching frequency around 10 kilohertz. 10 kilohertz. Okay. So next I'm going to measure the PV data. So I'm going to measure PV voltage and current and power. So I need 3 input port and 3 layout. So I'm going to measure this PV, current, voltage, current and power. So power I'm going to take product. Okay, this one. So next we need to design this value, right? Capacitance and inductor for that boost converter. So here you can go to that. This is a standard code used for designing LNC. So we need to provide PV power, input voltage, switching frequency, output voltage requirement. Okay. So the remaining equation used for calculating LNC. Okay. So I'm going to simulate this one. So this is LNC value for that boost converter. So I'm going to change this value to this, and I'm going to copy this one, change the capacitance here and here also. Okay. So now that the first stage is completed, that means a DC to DC conversion in the double stage conversion. So next we go for inverter section, right? I'm going to use universal bridge. I'm going to rotate this one. I'm going to change this one to IGBT diode and change the terminal to up. Change the position of the terminals. Next I'm going to measure the voltage after inverter 3-phase measurement. So I'm going to use label here. So here I'm going to consider V inverter, and this is I inverter, and then I'm going to connect this one here. So next I'm going to use inductive filter, and then next I'm going to measure grid side voltage and current. So here I'm going to change VG, IG, and then next we need to use three phase source, and then I'm going to rotate this one. I'm going to change this one is 400, this one is 50, and then here I'm going to change the position of the terminals. That means ABC here. Okay. So next you need to design this one L value, right? So for that we have equation, that means L design. So here we need to provide the power of PV, DC link voltage, AC voltage, okay, and then switching frequency, and then after simulating this one we have that inductor. Okay, inductor really just you have to use the same inductor for this three phase. Okay, so this designing is over, so we go to use control logic. So here we have to use voltage control and current control. So I'm going to measure that when we need to use DC link control, DC link voltage control, and then should be compared with the constant. So because here I need to maintain voltage around 600 here, right? So here I'm going to maintain 600. So from PV we have around 319 volt. Okay. So for that only here we are using that voltage control, and I'm going to use some, and then this is going to be compared here. So I'm going to change this one to minus plus, and then this is going to be processed via PID controller, and this will be provide current reference, that means direct access current, because we are going to use a DC control method. So this is going to be provide direct access current reference. So before that we need to use we need to convert that detail into per unit. So I'm going to use gain block, and then here I'm going to connect and divide with the 600. Okay, next I'm going to use max. So I'm going to take a dq, this is going to act as a q, right? So next I'm going to measure vg. Okay, so here I'm going to use from block, and then I'm going to take a vg. So by using vg, the vg going to be processed via pll. So pll three phase, and then here need to change to 50 hertz, and then I'm going to take go to measure the omega for converting the grid current ABC to DQ form. Okay, so for that only we are using that PLN. Okay, so I'm going to take this one. So next I'm going to measure uh, grid current. So here I'm going to change VG to IG, and this should be converted into per unit value. So I'm going to connect gain. So here I'm going to use 400 divided by 3048000, the voltage divided by power, right? So this is going to be converted into per unit, right? So next we need to convert this one to ABC to DQ naught. So I'm going to use ABC to DQ naught. So this is given to here, and then this is given to here. So now we have DQ naught. So here we need to use only DQ. Okay, so just go to Dmax. Dmax is one, and take only DQ, right? Just go to take that DQ, right? So next I'm going to use summing block to compare that current, this reference current with the actual current. Okay, so here I'm going to take plus minus, and then it's going to be processed via PID controller. So now here we have controlled voltage in the form of VDQ, right? So next I'm going to change to DQ to DQ naught. Okay, and then this control voltage in the form of DQ, so that should be converted into ABC form. So I'm going to use DQ not to ABC, and then here I'm going to connect omega t. So after that you have that ABC form, control voltage in the ABC form, that should be processed via PWM generator. That means sinusoidal PWM generator. So I'm going to use PWM generator 2 level, and then this is going to be connected here, and here I'm going to change to that means switching frequency is equal to 10 kilohertz, right? Now I'm going to connect this one to here, right? So this is a complete model of the solar 3 megawatt grid connected solar PV system. So next we need to measure the grid voltage, grid current, and inverter current, inverter voltage, and then we need to measure power of this grid side, right? Grid and the inverter side. So for that I'm going to take this one, grid voltage, grid current, and then I'm going to take inverter voltage, right? So just I'm going to change to inverter voltage. So this is uh, inverter current. So I'm going to measure these details. So here need to measure 4. So just to go to configuration, change number of port is 4 and layout is 4. Apply and then connect the details. Grid voltage, grid current, inverter voltage, inverter current. So and also you have to measure power. So further go to here measurements and then take this one fast sequence measurements. That means you have to measure the power in the grid side as well as inverter side. So just change to 50 Hz frequency. So here you have to measure inverter power, right? So here connect that this one. Okay. So now I'm going to measure this detail. So I'm going to measure only real power of inverter side and grid side. So I'm going to use two layout. So this that means power of grid and power of inverter. So next we need power GUI block, right? So power GUI, right? So everything fine. I think the complete model is ready, right? So we need to get this model first. So I'm going to save this model and then play this button. So after that, definitely we have some problem. Okay. So the sample rate we need to fix. So you got to fix this one, and then you got to simulate again. So before that, I need to connect another scope for the DC voltage and another scope for the control voltage from sorry control voltage from this inverter control logic, and also I need control output from that duty cycle from the MPPT. Okay, so I'm going to simulate now. We will check the results of the model, right? So we designed this model for 3 megawatt grid connected PV system, right? So first you have to check the PV power. So now we can see that the PV power is increasing, right? So it goes to 3 megawatt area, right? That means yeah, is going to settle at 3 megawatt, right? 3 into 10 power 6, right? So here voltage is around 319 at 320 volt. So here you can see that current, right? So current around 9,000, 9,500 something, right? So next we need to check this DC voltage. So here DC voltage is around 1200, is keep on reducing because we are fixing at 600 volt. So after some time it will reach that 600 volt. Okay. So next we need to check this, that means grid voltage, current, everything, right? So here I'm going to change the time display to 0.1 second, so then only you can see the structure of this. This is grid voltage, so this is grid current, so this is inverter voltage, so this is inverter current. So next we need to check power of the grid and the power of inverter. So this is the power of grid, power sent into the grid. So this is power from that inverter. Okay, so here you can see that is reaches maximum to that nearer to that 3 megawatt, right? So whatever power is generating from this PV, right? Here you can see here, right? So here you can see that whatever power is generating is sent to grid, right? So this is grid power. So this grid voltage, grid current, inverter voltage, and inverter current. Okay. So now I'm going to change the irradiation, and then we will check the result of this model. So I'm going to change the irradiation to 500, and then we will check the results. Now we can see that because of change in irradiation is around maintained at 1.5, right? So the maximum power is extracted from the PV panel, and also because of change in irradiation the power sent into the grid also changed. So here you can see that this power is around 1.5 megawatt, right? And also you can see here, right, change in current in the grid side, right? So this is working of 3 megawatt grid connected solar PV system. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming video. Thank you once again.